In this video, we're going to complete the KutaSoftware Infinite Algebra 2 free worksheet, all matrix operations. Our instructions are to simplify, write undefined for expressions that are undefined. So with all matrix operations, we're going to be adding, subtracting, multiplying, and scaling matrices. And remember, undefined occurs when an operation cannot be executed. And if you're confused on any of that, go to a previous worksheet where I take multiplying matrices and go more in depth with that, and then an even earlier worksheet where I go over adding, subtracting, and scaling. But if you feel comfortable with each of those, let's jump into number 1 for some good practice. In number 1, our first question, can we multiply these things together? We have a 2 by 2 matrix, that's 2 rows by 2 columns. And then we're multiplying that by another 2 by 2 matrix, 2 rows by 2 columns. Therefore, we know we can multiply because the columns of the first match the number of rows of the second. And the result is going to be 2 by 2. And remember, the way we multiply is we dot the first row with the first column, and that gives us the element in row 1, column 1. And then we dot the first row with the second column of the other matrix, and that will give us the entry in row 1, column 2, and so on. So writing number 1 all the way out, I'll start by dotting row 1 with column 1. So that's going to be 2 times 4 plus -1 times -3. Now I'll dot the first row with the second column. That'll be 2 times 4. And I'll add that to -1 times -5. Now on to figuring out my second row. -6, 1, dotted with 4, -3. That would be -6 times 4 plus 1 times -3. And then dotting the second row with my second column, that's going to be -6 times 4 plus 1 times -5. Now, I just have to finish out the math. Looking at my entry in row 1, column 1, I have 2 times 4, which is 8, plus -1 times -3, so 8 plus a +3 will give me 11. Now, looking at the second column, but still that first row, 2 times 4 gives me 8, and I'll add that to -1 times -5, which is a +5. 8 plus 5, that's going to be 13. Now, looking at my second row, first column, I have -6 times 4, which is a -24, and I'll be adding that to 1 times -3, which is a -3. -24 minus 3, or plus -3, gives me a -27. And then, finally, my last row, last column, I have -6 times 4, which is -24, and I'll be adding that to 1 times -5, which is adding a -5, or simply subtracting a +5. Either way you want to think about it is correct, and that gives us -29. So my matrix in number 1 is 11, 13, -27, -29. Let's move on to number 2. In number 2, remember order of operations still applies within matrix operations. So because I have parentheses here, I'm going to need to add these 2 matrices first. So I'll just rewrite this first matrix, 2, 6, -6, 4, and this one will get multiplied by the sum of these 2 matrices. So when I sum matrices together, they need to be the same exact size. And I have a 2 by 2 added with a 2 by 2, which those are the same size, so I can add those together. The result of this is going to be a 2 by 2. Now let's double check to make sure we can multiply before we do out all this work. So I'm going to have a 2 by 2 multiplied by a 2 by 2, which I can do. So let's go ahead and add these matrices together. Now when adding, I'll take an entry in one place and add it with the entry in the same place in the other matrix to get that resulting entry. So first row, first column will be 5 plus 1, which is 6. Then I'll do 3 plus 2, which will give me 5. And then negative 6 plus 2 gives me negative 4, and 2 plus 0 will give me 2. So now that I have the resultant sum, I can simply multiply. 2 by 2 multiplied by a 2 by 2 will give me a 2 by 2. So dotting the first row with the first column, I'll have 2 times 6, which is 12, plus 6 times negative 4, which is negative 24. So I'll write that as 12 minus 24 for that first dot product. And then I'll take 2, 6, dot it with 5, 2. 2 times 5 is 10, and I'll be adding that to 6 times 2, which is 12. So 10 plus 12. Now, working on my second row, I'll dot negative 6, 4 with 6, negative 4. That's going to be negative 6 times 6, which is negative 36, plus 4 times negative 4, which is negative 16. So negative 36 minus 16. And then last row, my second row, dot it with my last column, my second column, will give me my entry in row 2, column 2. So I'm going to have negative 6 times 5, which is negative 30, plus 4 times 2, which is 8. Negative 30 plus 8. Now let's finish out this math. 12 minus 24 gives me a negative 12. 10 plus 12 gives me a positive 22. Negative 36 minus 16 will give me a negative 52. And then negative 30 plus 8 will give me a negative 22. So negative 12, 22, negative 52, negative 22 is my solution in number 2. Or if you're reading by columns, negative 12, negative 52, 22, negative 22. Let's move on to number 3. In number 3, I have a 2 by 2 matrix, and I'm multiplying it by a 2 by 2 matrix. So we can indeed multiply, and the result is going to be a 2 by 2. So, dotting my first row with my first column, negative 1 times negative 3 gives me a positive 3, and I'll add that to 5 times negative 3, which is negative 15. So I'll subtract 15. Then, dotting negative 1, 5 with 6, 0, negative 1 times 6 is negative 6, and I'll add that to 5 times 0, which is 0. Now, working with my second row and first column, 5 times negative 3 is negative 15, and I'll add that to negative 5 times negative 3, which is a positive 15. And then lastly, 5, negative 5, dot it with 6, 0. 5 times 6 is 30, plus negative 5 times 0 is 0. Now let's go ahead and finish solving for each of those entries. 3 minus 15 is a negative 12. Negative 6 plus 0 is negative 6. Negative 15 plus 15 is 0. And 30 plus 0 is 30. So there's my matrix. Negative 12, negative 6, 0, 30. Let's move on to number 4. So remember, order of operations matters, so we're going to start by multiplying my matrices together. So the first matrix multiplied by the second matrix. So let's see if this operation can even happen. I have a 2 by 2 matrix, and I'm multiplying that by a 2 by 1. So, because the number of columns in my first matrix matches the number of rows in my second matrix, I can indeed multiply those together. However, the result is going to be a 2, the number of rows in the first matrix, by 1, the number of columns in the second matrix. So now, after I multiply, I'm going to have a 2 by 1, and I need to add that to a 1, 2, 3, 4 by 1. So right away, there should be a red flag going up, because in order to add matrices together, they need to be the same size. and a 2 by 1 is not the same size as a 4 by 1. So without really doing much work, we know the answer for number 4. It's undefined. Because we cannot successfully execute all the operations, we cannot do this problem out. Therefore, we say undefined and move on. In number 5, we're adding matrices together, and in order to add, they need to be the same size. So we have a 4 by 1, and we're adding that to a 4 by 1. Same size, so we can indeed add. And that's going to give us the same size. So I'll do -2 plus -4, or -4, then -3 plus 6, then -6 plus 0, and then 2 plus -3, or 2 minus 3. Working top to bottom, -2 minus 4 is -6, -3 plus 6 is a positive 3, -6 plus 0 is -6, and 2 minus 3 is -1. -6, 3, -6, -1 is my matrix in number 5. In number 4, I'm going to be multiplying matrices first because I have parentheses, and then I'll be scaling it. So let's multiply these together first. I have a 2 by 2 multiplied by a 2 by 2, therefore I can indeed do out the math. So I'll have -4 times, dotting the first row with the first column, -3 times -2 is a positive 6. And I'll be adding that to -6 times -1, which is a positive 6. Then I'll dot the first row with the second column. -3 times 6 is -18, and I'll be adding that to -6 times -4, which is a positive 24. Then working with my second row, 1, 4, I'll dot that with -2, -1, which 1 times -2 is -2, plus 4 times -1 is a -4, so -4. And then 1, 4, dot it with 6, -4, 1 times 6 is 6, plus 4 times -4 is -16, or simply -16. Now, I have -4 times, let's simplify this matrix. 6 plus 6 is 12. -18 plus 24 is a positive 6. -2 minus 4 is a -6. And then 6 minus 16 is a -10. So now when I go to scale this matrix, I simply multiply -4 to each of my entries. So I'm going to have -4 times 12, which is a -48. And then -4 times 6 is going to be -24. Then -4 times -6 is a positive 24. And -4 times -10 is a positive 40. And that's my solution in number 6. -48, -24, 24, 40. Let's move on to number 7. In number 7, I'm adding and multiplying matrices, but first we need to multiply. Let's see if we can. We have a 2 by 2 multiplied by a 2 by 3, which we can indeed multiply, because the columns of the first match the number of rows in the second. The result of that is going to be a 2 by 3. So can we add? Yes, because this is a 2 by 3, and the result of this multiplication will be a 2 by 3. They will be the same size, therefore we will be able to add. So let's go ahead and figure out the 2 by 3 matrix that we get after multiplying. So I'll rewrite this first matrix, 3, 1, 3, 0, 5, -3. And I'll add that to, well, dotting first row with first column, -1 times 0 is 0, and I'll be adding that to 3 times 1, which gives me positive 3. I'm going to do a lot of this math in my head to help simplify so that I don't run out of space on my worksheet, but feel free to write a little bit smaller and write out all of the steps if you're uncomfortable with doing mental math. Or if your teacher requires you to write out all the steps, do so. But continuing on for now, I'm going to then dot my first row with my second column. That's going to be -1 times -6, which will be a positive 6, and I'll add that to 3 times 1, which will be a positive 3. 6 plus 3 gives me 9. Now I'll take that first row and dot it with that third column. -1 times -1 gives me a positive 1, and I'll add that to 3 times 4, which gives me 12. 1 plus 12 is a positive 13. Now I've got my first row complete, so all I gotta do is my second row. So that's going to be 6, 1, dotted with 0, 1. 6 times 0 is 0, plus 1 times 1 is 1, so 0 plus 1 gives me 1. Now, dotting my second row with my second column, 6 times -6 is -36, and I'll be adding that to 1 times 1, which is positive 1. -36 plus 1 is a -35. And then, dotting my second row with my third column will give me the entry in row 2, column 3. So 6 times -1 is a -6, and I'll add that to 1 times 4, which is a positive 4. -6 plus 4 gives me a -2. Now, I can simply add these matrices together. Same size, I can go ahead and add, which we had already double checked before we even started. No reason to do more work than we have to. So 3 plus 3 gives me 6, 1 plus 9 gives me 10, 3 plus 13 gives me 16. First row is complete. Now on to the second. 0 plus 1 is 1. 5 plus -35, or 5 minus 35, is -30. And then -3 plus -2, -3 minus 2, is a -5. And there's my solution for number 7. 6, 10, 16, 1, -30, -5, or reading by columns, 6, 1, 10, -30, 16, -5. Now on to number 8. Remember, order of operations matters. So I'm going to be adding those matrices first, which I can indeed, because I have a 3 by 1, add it to a 3 by 1. The result will also be a 3 by 1. Same size, so I can add. After I'll add, I'll then scale it. So let's rewrite -5 over here. And now let me add my two matrices together. 2 plus 2 will give me 4. -1 plus -4 will give me -5. And then -6 plus 4 will give me -2. Now I'll just multiply everything by -5. -5 times 4 is -20. -5 times -5 is a positive 25. And -5 times -2 is a positive 10. -20, 25, 10 is my solution in number 8. Now, let's move on to that second page. Now, in number 9, we have addition and multiplication, but multiplication comes first. Let's double check that we can complete all of our operations. So we have a 2 by 2 matrix, multiplied by a 2 by 2, the result will be a 2 by 2. Then we can definitely add a 2 by 2 by a resulting 2 by 2 because they're the same size. So we can do all these operations, so let's move forward on the problem. Now I'll just rewrite the matrix out in front, -1, -1, -6, 3, and I'll be adding that to, let's go ahead and do out the math. Dotting -5, -1 with 3, 1, -5 times 3 is a -15, and I'll add that to -1 times 1, which is a -1. -15 minus 1 is a -16. Now, I'll dot the first row with my second column. -5 times 6 is -30, and I'll add that to -1 times 6, which is a -6. So -30 minus 6 is -36. Now, Moving on to my second row, negative 4, 2, dotted with 3, 1. Negative 4 times 3 is a negative 12, and I'll add that to 2 times 1, which is 2. Negative 12 plus 2 gives me a negative 10. And then lastly, negative 4, 2, dotted with 6, 6. Negative 4 times 6 gives me a negative 24, and I'll add that to 2 times 6, which is 12. Negative 24 plus 12 gives me a negative 12. Now, because I have the same size matrices, I can go ahead and add. Negative 1 plus negative 16 is a negative 17. Negative 1 plus negative 36 is a negative 37. Negative 6 plus negative 10 is negative 16. And 3 plus negative 12 is a negative 9. Negative 17, negative 37, negative 16, negative 9. That's my solution in number 9. Moving on to number 10, I'm going to be subtracting matrices. But first, I have to scale this matrix. So I'll rewrite negative 2, negative 6, and I'll be subtracting that from 3 times negative 6 is a negative 18, and then 3 times 0 is 0. Now, because my matrices are indeed the same side, I can go through with this subtraction. Negative 2 minus a negative 18 is negative 2 plus 18, which is a positive 16. And then negative 6 minus 0 is negative 6. So 16 negative 6 is my solution in number 10. Now for number 11, I'm going to scale the matrix first and then add. And remember, scaling doesn't change the size of the matrix. So I have a 2 by 3. After I scale it, it will still be a 2 by 3, and I can add a 2 by 3 to a 2 by 3. So let's scale this matrix. Negative 2 times negative 3 is a positive 6. Negative 2 times negative 5 is a positive 10. Negative 2 times negative 5 is a positive 10. That's my first row. Now, negative 2 times 0 is 0. Negative 2 times 5 is a negative 10. And then negative 2 times negative 6 is a positive 12. So after completing scaling that first matrix, I'll add that to 4, negative 1, negative 3, 6, 3, 2. Adding those, 6 plus 4 gives me 10. 10 plus negative 1, 10 minus 1 gives me 9. 10 plus negative 3, 10 minus 3 gives me 7. 0 plus 6, that's 6. Negative 10 plus 3, that's negative 7. And then 12 plus 2, that's 14. So 10, 9, 7, 6, negative 7, 14. That's my solution in number 11. Now for number 12, remember, order of operations matters. So we're going to be adding first. So we have a 2 by 3 plus a 2 by 3, which we can indeed do, and that result will be a 2 by 3. Can we multiply? We totally can, because a 2 by 2 multiplied by a 2 by 3, the columns of the first match the number of rows in the second, and that result will be a 2 by 3. So let's go ahead and add, and then multiply. So I'll just rewrite this matrix, negative 5, 1, negative 4, negative 5, and then I'll add my 2 by 3s. So 5 plus 3, that gives me 8. Negative 4 plus negative 5 gives me negative 9. 2 plus 2 gives me 4. Negative 6 plus 5 gives me negative 1. 3 plus 5 gives me 8. Negative 6 plus 3 gives me negative 3. Now, 2 by 2 multiplied by a 2 by 3 will result in a 2 by 3. So I'm going to dot the first row with the first column. Negative 5 times 8 plus 1 times negative 1. So that's going to be negative 40 plus negative 1, which is negative 41. And then first row dotted with the second column, negative 5 times negative 9 is a positive 45, and I'll be adding that to 8 times 1, which is 8. So 45 plus 8, that's going to result in a positive 53. And then negative 5, 1, dot it with 4, negative 3. Negative 5 times 4 is negative 20, and I'll be adding that to 1 times 3, which is a negative 3. So negative 20 plus negative 3, that's negative 23. Now, onto my last row, negative 4, negative 5, dot it with 8, negative 1. Negative 4 times 8 is negative 32, and then I'll add that to negative 5 times negative 1, which is a positive 5. Negative 32 plus 5 is going to be a negative 27. Then, second row, dot it with second column. Negative 4 times negative 9 is a positive 36. And if you need help multiplying by 9, check out my really neat math trick video. I'll leave a link in the description below, but it'll make multiplying by 9 so easy. So check it out. So negative 4 times negative 9 is positive 36, and I'll add that to negative 5 times 8, which is a negative 40. So I'll be subtracting 40. 36 minus 40 is going to be negative 4. And then lastly, negative 4, negative 5, dot it with 4, negative 3. Negative 4 times 4 is a negative 16. And I'll add that to negative 5 times negative 3, which is a positive 15. Negative 16 plus 15 is a negative 1. So negative 41, 53, negative 23, negative 27, negative 4, negative 1. That's my solution in number 12. In number 13, they mix things up a bit by throwing in some variables. But we still go about adding or multiplying the same exact way. So first of all, let's double check that we can complete all of our operations. We have a 2 by 2, and we're adding that to a 2 by 2. We can totally add matrices of the same size. That result is going to be a 2 by 2. Now, can we multiply a 2 by 2 by a 2 by 1? Yes, we can. Because the number of columns of the first match the number of rows in the second, the result will be a 2 by 1. So because we can do all of these operations, let's go ahead and complete 13. So adding my matrices first, I have negative 4y plus 2y, like terms, that's going to be a negative 2y. Then I have 2y plus 6. Can't combine those, so I'll just rewrite it. Then 2 plus 2, that's 4. And then 3 plus 2x is going to be 3 plus 2x. Now I'll be multiplying that by 5, negative 5. So we have our first row dotted with our first column, or essentially our only column. So that'll be 5 times negative 2y, and I'll add that to negative 5 times 2y plus 6. So that's my first row. Now dotting my second row with my first column, my only column, in that second matrix, 4 times 5 plus negative 5 times 3 plus 2x. So that's 4 times 5 plus negative 5 times 3 plus 2x. Simplifying this a little bit further, I have 5 times negative 2y, which is negative 10y, and I'll be adding that to, I have to distribute that negative 5. So negative 5 times 2y is another negative 10y, and then negative 5 times 6 is a negative 30. And then 4 times 5, that's going to be 20, and I'll add that to, again, I need to distribute this negative 5. Negative 5 times 3 is a negative 15, and I'll add that to negative 5 times 2x, which is negative 10x. Now, combining my like terms, Finishing simplifying this down, negative 10y plus negative 10y is negative 20y. And then adding a negative 30, I'll write that as subtracting 30. So that's my first row. Now, looking at my second row, 20 plus negative 15 is 20 minus 15, which is a positive 5. And then adding a negative 10x, I'll subtract a positive 10x. So my solution is a 2 by 1, negative 20y minus 30, and then 5 minus 10x. So I have one element in row 1 and one element in row 2. Now, moving on to number 14, the last one that I have to do computationally. So, first we're going to multiply, and then we're going to subtract. So if we have a 2 by 2, and we're multiplying that by a 2 by 2, the result is a 2 by 2, and I can indeed subtract a 2 by 2 and a 2 by 2. So let's go ahead and complete number 14. So doing the multiplication first, I'll dot row 1 with column 1. So that's 6y times negative y, which is negative 6y squared, and I'll be adding that to y squared times negative 6, which is a negative 6y squared. Now, I'll dot my first row with my second column. 6y times xy is 6xy squared, or 6y squared x. And then I'll be adding that to y squared times x squared, which is y squared x squared. And remember, we're going to be subtracting 6y, negative 6, negative 3y, y, which I'll just quickly rewrite. Now moving on to the second row, I'll do negative 2y, dot it with negative y, negative 6. Negative 2y times negative y is a positive 2y squared, and that will be added to negative 2y times negative 6, which is a positive 12y. And then, second row, dot it with second column. Negative 2y times xy is negative 2y squared x, and I'll be adding that to negative 2y times x squared, which is negative 2y x squared. So before I go ahead and subtract, I'm going to simplify my matrix that I just computed. So I'm going to do negative 6y squared plus negative 6y squared. Combining those like terms is a negative 12y squared. And then 6y squared x plus y squared x squared cannot be simplified any further. So I'll rewrite that as 6y squared x plus y squared x squared. Because all of my exponents do not match, I cannot add those terms together. Next, I'll have to rewrite 2y squared plus 12y because those cannot be combined because they do not have similar exponents. So 2y squared plus 12y. And then lastly, I have negative 2y squared x plus negative 2y x squared. Those cannot be combined, so I'll rewrite that. Negative 2y squared x minus 2yx squared. So that 2 by 2 matrix, I'll subtract another 2 by 2. 6y negative 6, negative 3y, y. So doing out the math, negative 12y squared minus 6y, nothing can be combined. So it's just going to be negative 12y squared minus 6y. And then 6y squared x plus y squared x squared minus a negative 6, that's the same as adding 6. Nothing can be simplified, so I'll write it as is. 6y squared x plus y squared x squared plus 6. And then 2y squared plus 12y minus a negative 3y, that's 2y squared plus 12y plus 3y. So I can combine things in this case because 12y plus 3y gives me 15y. So I'll have 2y squared plus 15y. And then lastly, negative 2y squared x minus 2yx squared minus y. Nothing can be combined, so I'll rewrite that. Negative 2y squared x minus 2yx squared minus y. That's my solution in number 14. Negative 12y squared minus 6y, 6y squared x plus y squared x squared plus 6, 2y squared plus 15y, and then lastly, negative 2y squared x minus 2yx squared minus y. Now onto my favorite part of these worksheets, the critical thinking questions. In number 15 it says, give an example of a matrix expression in which you would first perform matrix subtraction. So I'm going to underline first, matrix subtraction, and then matrix multiplication. Use any numbers and dimensions you would like, but be sure that your expression isn't undefined. So in order to perform matrix subtraction, the matrices need to be the same size. I'll write this 1, 2, 3, 4, and I'll give it a little bit more space. And because I have a 2 by 2, I need to have the same size in order to subtract. So I'll subtract 5, 6, 7, 8, another 2 by 2. Now because matrix subtraction needs to be performed first, I will put this in parentheses. And now remember, a 2 by 2 minus a 2 by 2 results in the same size matrix, a 2 by 2. So now, what's my other matrix have to be in order to multiply? Well, it depends what side I want to multiply by, because left multiplication is different than right multiplication. Multiplication is usually commutative except when it comes to matrices. So if I tried to multiply this expression by a 3 by 2, I can't multiply the 3 by 2 on this side because 2 does not match 3. However, I can multiply it on this side because 2 matches 2. So you can see writing a matrix on the right versus writing a matrix on the left, right multiplication versus left multiplication is very different. But if I had a 2 by 2 matrix, I can multiply it on either side because a 2 by 2 multiplied by a 2 by 2 or a 2 by 2 multiplied by a 2 by 2, the rows and columns are all the same size, so I could multiply regardless of the side. So I'll go ahead and just write this as some left multiplication. So I'll write 1, 2, and I'll switch up some numbers. Let's do 9 and 10. So 1, 2, 9, 10 will get multiplied by the difference of 1, 2, 3, 4, 5, 6, 7, 8. You could throw some variables in there. We could write the matrix on the other side. Either way of going about this is fine. Just make sure that it is possible to complete all your operations. So let's look at number 16. In number 16, it says A, B, and C are matrices. A times B plus C, adding those matrices first, is equivalent to A times B plus C times A. Now this seems like it would be true because with matrices you can distribute. A times B will then be added to A times C. However, remember, multiplying on the left is different from multiplying on the right. So because this is A times B plus C times A, that matrix is not on the left-hand side like it should be when we distribute. Therefore, this is not always true. It is, however, sometimes true. Because think about this. If A and C were the same exact matrix, let's say that they're 1, 1, 1, 1 for A, and let's make C that same thing, 1, 1, 1, 1. If A is that and C is that same thing, it doesn't matter which side we multiply it on. the result will be 1, 1, 1, 1, regardless of the side we multiplied on. So this is true if C is equal to A. Can you think of another case that this would be true? Well, think about if we had a matrix full of zeros. 0 times anything is always 0. So multiplying by the right or the left, a matrix of all zeros, shouldn't make a difference either. So in number 16, our answer is sometimes true, because the big takeaway is multiplying a matrix on the left versus on the right is not commutative. So just remember that when moving forward with matrix operations. And with that, we wrap up this worksheet, all matrix operations. If you have any questions, leave them in the comments below. And if you want ways to support me, become a patron. By becoming a patron, you get to help choose the next videos that I record. So if you want to make a difference, or you want to make an impact on my channel, become a patron. But your biggest way to support me, as always, is to like, subscribe, and share. Thanks again, and happy learning!